light and the swift current because it flushes away the lighter minerals, leaving the heavier ones behind. You want to go into the sand, and you get that much. You get a little bit of contamination, but not too bad. And this may still be magnetic. It's quartz with iron in it. And I bet that would be great for the piezoelectric effect if you can grind it against other quartz with iron in it. Because quartz by itself, if you grind them together, will spark and glow inside because of the electricity you generate by crushing crystals together. That's how the energy is released when you break those bonds. It has to have somewhere to go. Then it goes from higher to lower energy state. Oh wow. I wonder if that's... Let me try something. No, it's not. If you find a stone that's magnetic, it's called a lodestone. Because all the natural magnetic lines that you can see here, when it's naturally lined up like that, because of how it formed, with them in line, it creates a natural magnet. And the plastic bag so I can take this off later and not have a bunch of iron on my magnet. It's for convenience. I'm just stirring up the gravel and the sand and letting it deposit. It doesn't work as well because of heavy minerals on here. The ones that float away are not the ones where the iron is. This is the kind of rock you want to grind with other quartz rocks. And it'll, because it's translucent, you'll be able to see the electricity in it. And it will glow in the dark when you grind it. Just a very faint glow from the piezoelectric effect. So I'm stirring it with my finger, trying not to knock off the iron, but just to get access to it. A lot of these are magnetic, but only because they have bits of iron in them. So to separate it out, you'd have to crush them. So the finer the grain of this iron, probably the more pure it's going to be. And then you can reduce it. Oxidation is loss, so oxygen is the natural form of iron, comes with rust and oxygen in it, other oxides like this. And then reduction is gain of electrons. That's the kind that's more pure. You have to go through that process to get the oxygen off. The oxygen molecules off of it. So you can see how much I got in just that little bit of time. But I still have to dry it out and separate it. Classify it, they call it classifying it, when you separate the big chunks from the small. That wasn't as effective, but I still have plenty of iron from this. So I need to get this bag off so I don't waste my magnets, but it'll keep the it keeps the iron separate from the magnets, so I don't have to fight it forever to get it off. You can see the lines of magnetic force. And generally they like to go like that. In one side, not the other, for these round magnets. Bar magnets, it'll go around and around. So there will be a positive side and negative side, and it'll go perpendicular to those. So you'll see this. I guess it goes perpendicular to the magnetic force is probably more accurate. I don't know. Have to look at it now.